Hey folks, I've downloaded the latest E-Series Centricity Simulator package that you can get from NetApp Field Portal for employees and partners, or for customers, get them from those two groups that I just mentioned. Once you get this package, you can unzip it, and in the unzipped folder, you will see a bunch of files. The first one you would read would obviously be readme_user_guide.pdf, but there are two important folders or directories to mind. The first one is simulator, the other one is configs. So those are the only ones, maybe certificates if you really want to experiment with that. But simulator is the one that contains only one, no more, no less, configuration file, and this will be the one that will be used by the simulator when you fire it up. If you don't like what you see there, by default it's EF300 with hybrid shelves. You can go here and use a generic 3000 series or 6000 series simulator and copy and paste it to that config, and then delete the one that is there by default. Now I will not do that. I'm happy with what I have, so I will start the simulator by reading which file to run. In my case, it's all_restartup.bat for Windows. For Mac or Linux, it will be all.sh. Now you can see it takes a while to start this thing. It's Java-based, so of course no wonder. You have to wait, and then after about 70 to 90 seconds, it will open the default browser and you will be able to log in. And then there was another screen where I entered the loopback interface address 127.0.0.1, and I discovered the array from the simulator directory EF300 with SAS expansion. Then I selected it and clicked launch. That gives us finally the interface to manage our simulated EF series array. Now, if you just want to see how to use it, that's it. You can now close this or stop this video, but if you want to see about hot spares and how DDP allocates spare capacity, keep watching. Now, you can see that in here we have two different disk drive formats. We have 2.5-inch NVMe in the controller shelf. If we want to assign hot spare for those, I pick one of those disks, right click on it, and make it a hot spare. Now, this one can serve only the same shelf. In this case, this is because only the shelf is NVMe, and also drives that can be protected by this hot spare must be same or smaller. Now, I will create two RAID groups or volume groups, and I will show that each one will make use of that hot spare, i.e. it will be a global hot spare. I don't have to care about the controller or other things. They will just share it. I'll create another one. This time I will use RAID level 5 to show also that you don't have to care which RAID level is used. And now when I examine these two groups, I will see that each of them is hot spare protected. Yes, and the other one, yes as well. So I'm doing this with just one hot spare in slot 23, the last slot in this shelf. So no matter how many I create in this shelf, they're all the same size, and therefore they can be protected by one SSD, NVMe SSD at the very end. If I wanted to, I could certainly assign another one, like I did here. I can also unassign it. Now, because I assigned it and now I'm unassigning, you can see that the two RAID groups automatically assumed or took advantage of that new additional second drive. Now let's go to DDP. Here I will intentionally start with hard disk drive based. I have no hot spares there and I need a lot of drives, so one shelf will not be enough, so I will need to use multiple shelves in any case. So I've started with 11 sized DDP. Now you can see it says RAID level 6. Why is it a RAID level 6 when I'm using DDP? Because internally DDP writes in an 8+2 fashion. So there's also no hot spare. Now DDP automatically creates one disk drive of spare capacity, or at least one disk drive worth of spare capacity across the entire pool when it starts with 11. So in this case, I've got 50.9 terabytes, and when I grow this, it will try to increase that capacity, preservation capacity, to provide better protection. Now, I don't want to do this. Why? Because I want to compare this with RAID 5 that is equally wide. So I will cancel this. So as to leave one spare drive of unused capacity in this pool. Now that I increased the size, it is 17 drives in this DDP. It's still using RAID level. It writes in stripes that contain 8 chunks of data and 2 chunks of parity. Now you can see it's still 1 drive worth of spare capacity. Now if I were to create a RAID 5 group, in this case using the 17 drive limit that I set myself to work with, when I create this, you will see that of course RAID level is 5. This is what we decided. This is not a DPP, and it's using 17 drives, so it's 16 data, 1 parity. So it does contain a lot more capacity, and this can be explained not only by the fact that this is RAID 5, but also that it has no host pair overhead yet, right? Because they did not allocate it. So in order to make it a more fair comparison, I pick one of the shells where this array or RAID group is allocated, and then now it's using actually 18 disks. You can see it's host pair protected, right? So I just wanted to show you can assign and then it will be covered by it. So I will remove it because I currently don't care about the overhead of this drive. I'll just unassign this host pair. Now I will show you another thing, that when we start with 17 wide DDP, it will automatically allocate 2 drives or leave 2 drives of spare capacity across DDP. In this case, not ask you because you have not started with 11, where 1 would be 1 worth of spare capacity would be recommended value. When you start with 17, it's already 2, so there's no prompt, it just goes and does it. Now you will notice here that one has 1 drive worth of spare capacity, the other one has 2. They should not show same capacity, but they do. So it's a bug in simulator. I checked in Fusion, it does show difference. So the one with 1 is larger and can accommodate more. But in any case, this is why RAID 5 looks so much bigger in this case. Thanks for watching.